Hi, I'm Andrew Bunnell, and today let's take a look at how to calculate errors when we have more than one measurement. This is known as error propagation or uncertainty propagation. So let's step back for just a second and let's contrive a strange setting. All right, let's say you're in a competition. Now this competition is going to use markers to create a boat. And you need to be able to use enough markers to be able to float a certain object. And if you remember right, a marker is mostly hollow, has a little bit of liquid inside this little, in this container, but it's water. It's typically, with the lid on, it's water resistant, and so it's not going to leak water in here. And so our goal is to try to get an average mass density of this marker so that we know how many markers we're going to need to hold up a certain object. And so how are we going to do that? Well, the first thing you would say is, well, I can put this on a scale and get the mass. Okay. And now I'm going to take a ruler and I'm going to measure the length. Okay. And measuring the diameter is a little bit hard for the volume. And so instead of that, I'm going to use a caliper. I'm going to measure the diameter, but they don't make markers perfectly, to a perfect tolerance. And so I'm going to take a couple measurements on a couple different markers. I'm going to take a couple measurements, and I could stack a couple markers together, and so that I could get a different average. And sorry about my ruler's a little bit green screeny, even though it's a yellow ruler. Okay, and so we can start to think about how we're going to find the volume and then find the mass and combine our errors. But we got, a length, and we got a diameter, and we got a factor of pi, and we also have two, it's radius squared, and so we have to divide the diameter by 2, and then we have to square it, and then we also have our mass measurement. So there's a whole bunch of measurements we're taking. We're combining them to get a single value. So how would we go about combining those errors? And that's known as error propagation. And so really quick before I jump right into start, error propagation, let's fade over to Moodle really quick. And here we got Moodle, and if you log into Hope College groups, and it says I'm already logged in, okay. And then I scroll down here to research training. Scroll down really quick. Down here under error propagation, I have two different versions of this presentation, one with LaTeX and one without LaTeX. We're going to be going over the one with no LaTeX, but I just want to double click, I just want to open this one up and rotate it really quick and show you that I have included all the LaTeX code for this presentation in this chapter, which has been slightly modified from the chapter in the GenPhys manual. And to the side, there's all the LaTeX code for every page. And so if you're interested from what you've learned last week and want to dive right into LaTeX, here's a lot of code to show you how to do all these complicated formulas. And then even down here, there's some, like a table, an array equation. Anyways, let's go ahead and fade over to the textbook now. And here we go. Here's our lesson for today, error propagation. And so we had this setup where we had multiple variables that are going to be combined, and each one's going to have uncertainty with it to get our final answer. And so if we have some sort of function, let's call our function Q. And it's composed of simply two variables. Let's call them x and y. And so this function Q is a function of x and y, where x and y are independent variables. Then the uncertainty of Q squared is defined as the uncertainty is defined as the partial derivative of Q with respect to x, quantity squared, multiplied by its uncertainty of x squared, plus the the partial of Q with respect to y quantity squared multiplied by the uncertainty in y, plus an additional factor where it's 2 times the partial derivative with respect to x multiplied by the partial derivative with respect to y multiplied by the partial derivative, or sorry, the uncertainty of xy squared. Now, just to let you know, this comes from an error matrix, and these two terms up here are the diagonal elements, and this term over here is 2 times the corner elements, and in this case it's a 2 by 2 matrix, and so we have 2 corners, and we have to add them. We have to multiply them by 2, and we add them. But that term is typically fairly small compared to these on-axis terms, and so we typically, to simplify our uncertainty, we can just drop that last term. And so if we had a function of x, y, and z, or more variables, you can just imagine how many more elements that would be in that matrix. And so to simplify our calculations, we're just going to focus on the on-axis elements. And so the standard deviation of q is the square root of this expression. So the sigma squared of q, we take the square root, and then we just take the square root of the other side. Okay, so that's all well and good and great. A couple of you haven't had multi-1 or multi-2 and haven't looked into partial derivatives. And don't worry, if you had just simple calculus 1, you understand the concept of a derivative. Partial derivatives, in some regards, are easier than derivatives. You just have to do a couple more steps. And so let's start to look at how we're going to take partial derivatives of simple things. The first one is just a really simple addition. So let's say q is a function of x and y, which are variables with uncertainty, and then a is like a constant. So that could be like any number, like 2 or 1 or -1. Okay, so we take the partial derivative. So looking back at our formula, we need to take the partial derivative with respect to x, partial derivative with respect to y, and multiply it by the uncertainty of x, and you know, it's squared as well. So typically to start out, you should just go ahead and write out this whole formula, and then we're going to do the first part. Okay, so let's look at this expression up here. Q is equal to x plus y plus a, and we're going to assume that x is the variable this time, and everything else is a constant. Okay, that's the partial derivative. And so this first term right here, x, what's the derivative of x with respect to x? And so that's just simply a 1. And so we put a 1 down here. Now this term right here is a y, but it doesn't have an x in it, and so it goes to 0. And a is a constant, so it goes to 0. Okay, so that's our first term. We have a 1 inside this parentheses right here, these brackets, squared times the uncertainty in x squared. Okay, that's our first term. Now we need to go back and do the next piece. Go back and do the next piece and take the partial derivative with respect to y. And so this first term right here of this expression doesn't have a y in it, so it goes to 0. The second one, there's just a y in there. Okay, and so the derivative of y with respect to the derivative of y is just a 1, and so that 1 goes right there inside the parentheses, and it's squared. And once again, this is just a number like a 5, and you know the derivative of 5 is 0. Okay, so that's why there's a 1 squared. And then if we were to take the partial derivative with respect to a, well, we really can't do that. It's just a constant, so it's just a 0. Okay, and so sigma squared of q is equal to 1 squared sigma x squared plus 1 squared, and that just goes to 1, sigma y squared. Great. And so the standard deviation of q is equal to the square root of sigma x squared plus sigma y squared. And that should look familiar. You've probably taken Gen Phys Lab, and you remember that formula. Okay, we take each component, each measurement, and if we're adding or subtracting, like for example, if we're measuring this marker with this ruler, we have the left side and we have the right side, and we have to consider the uncertainty on both sides, and so we're adding those two measurements together. And so we have to use this formula right there. All right, let's look at a little bit more complicated formula. Now we have an x, y, and z, and we have a minus sign in there, and we have a and b, so the x and the y are multiplied by some constant. We could say, you know, this constant right here is a 2 or a 1, and this constant, this b, could be any number as well. It could be 1 million. I mean, it can be any number, okay? So let's do this, okay? So first we're going to write down our expression. Sigma q squared is equal to the partial with respect to x squared times the sigma x squared. The partial with respect to y squared times sigma y squared. The partial with z squared to sigma z squared. Okay, great. Let's look at the partial of this expression. First off, with respect to x. Okay, so when I look at this expression, there's only an x in this first term, so those two go to 0. Now this first term, we have an a, and I'm going to go ahead and write down plus a squared. Okay, so that there's only an a left. The x goes to a 1. I could have written down a 1a in there, but you know, the 1 goes to, you know, the 1 just gets absorbed by the a, and so it's plus a squared times sigma x squared. Okay, now I look at this whole expression again with respect to y, and the first one and the last one go to 0, and we're just left with this middle term. The partial with a derivative of this middle term with respect to y, the y goes to a 1, and we're just left with a negative b. So the negative b goes in there, right there, and it's squared. And yes, we know that the negative's going to go away because the squared, but for the moment, let's just write that down. Okay, now let's look at the expression one more time and take the partial derivative with respect to z. Okay, we look at the first term, and there's no z in there, so that's 0. The second term, there's no z in there, so that goes to 0. And now the third term, there's just a z, and so that goes to 1. And so I put a 1 right there, and it's squared times z squared. And so we take the square root of both sides, and we're left with the square root of a squared sigma x squared, b squared sigma y squared, plus just sigma z squared. And one more time, just as a reminder, that negative that we started out with that expression just cancels out because of the squared. Okay, so now it's your turn. Let's go ahead and have you write this one down on your paper. Q is equal to 5x plus 3y minus 1. And let's go ahead and take a minute, write it down, write down this expression first, and then take the partial first with respect to y, then the partial with respect to, partial with respect to x, then the partial with respect to y. And remember, the constant goes to 0. Okay, let's take a moment, pause, and then come back to the video. Just as a note, the comments will have the answers to these problems, okay? Okay, so let's move on. So let's look at multiplication and division. Okay, right about there. Okay, basic multiplication rule. So let's say now Q is an expression or a function of x times y. And just as a reminder, it's x raised to the power of 1, y raised to a power of 1. And we'll see in just a second why this is important. Okay, so now we write down our whole expression. Sigma squared of q is equal to the partial of q with respect to x squared times sigma x squared. Partial with respect to y squared, sigma y squared. Okay, so now let's do it one step at a time. Let's take the partial of this expression with respect to x. Okay, so the x now is the variable. We take the partial of x to the first, and remember the 1 drops down, and then it's x to the 0 now. You have to subtract 1, and so that's x to the 1. So that's just left over 1, and so we have a 1 right there, and our y just is treated as a constant when we're taking the partial with respect to x, and so we're left with 1y squared. Okay, times it by sigma x squared. Great. Okay, so now let's look at this expression one more time. Now we're taking the partial with respect to y. Okay, we take the partial with respect to y. This time the y is raised to the first power, so the 1 drops down. It's 1 minus 1, so that goes y to the 0. Y to the 0 is 1, and so we're left with just a simple 1 and an x. And so we get left over 1x squared times sigma y squared. Okay, great. Now, we could take the square root of both sides, but there's a little trick when we're doing multiplication and division, where if we look at the ratio, or sigma q over q, we can actually simplify this expression and remember how to do it just really quickly and easy without going through all these partial derivatives. Okay, so let's take the relative uncertainty. Okay, so down here we're going to take sigma q squared over q squared. And so we have our sigma q squared up there that we had before, and let's take our initial expression, our q, and square it. So we get, instead of x to the first, y to the first, we get x squared and y squared. Okay, great. And now there's a little simplification that we can do right here. Okay, so maybe let's write this one down. Okay, so let's look at the first term only. The first term only. Okay, so y squared sigma x squared over x squared y squared. Well, the y squared and the y squared cancel, and we're left with a sigma x squared over x squared. Okay, now let's do the same thing. We're going to break up this denominator and put it over the second term. We have an x squared sigma y squared over an x squared y squared. Okay, the x squared and the x squared cancel, and now we're left with a sigma y squared over a y squared. Great. So that becomes sigma q squared over x squared over a sigma x squared over x squared plus sigma y squared over y squared. We can take the square root of both sides and move the q over to the other side, and we're left with sigma q is equal to q times the square root of sigma x squared over sigma x over x quantity squared plus sigma y over y quantity squared. And this should look very familiar to a formula you've used a lot in general physics. All right, so far so good. Let's go to a more complicated example. Great. Okay, so this time we have an x times y to the 1/3 times sine theta over z to the 4th. Well, that can be rewritten as x times y to the 1/3 times z to the -4th times sine of theta. Okay, so let's write down our equation so that we can go through each piece, okay? So sigma q squared is equal to the partial with respect to x squared sigma x squared, the partial with respect to y squared sigma y squared, the partial with respect to z times sigma z squared, and partial with respect to theta sigma theta squared. Okay, great. So let's do the first one first, okay? What's going to go inside of here? Okay, so we're going to take the partial of this term, or we could take the partial of this term with respect to x. When I put them in parentheses, I did this first term. So we just have an x to the first, x to the first. So x to the first, that becomes a 1. We're left with y to the 1/3 sine theta z to the 4th. And that's what we have right here. Let's look at this whole expression again and do it for y. Okay? Remember, we take the partial derivative of this, and now we're only looking at the y term with respect to y. And so the 1/3 drops down, and then we do y. This has to 1/3 minus 1, and so we get y to the -2/3, which is the same as putting the y on the bottom with the 2/3. And everything else stays the same. Okay, remember the 1/3 drops down, and then the y goes on the bottom, and it's become to the 2/3. Here we go. 1/3 x sine of theta z to the 4th y to the 2/3. Quantity squared sigma y squared. Okay, now this next one, the z's on the bottom. The z's on the bottom, but let's look at this one a little bit more, okay, on this side, okay? So to do a derivative of z, this z to the -4, we subtract 1, so, oops, sorry, we drop it down first. We drop it down first, and then we subtract 1, so that's z to the -5, and so that's the same thing as z on the bottom to the 5th. And here we go. And everything else stays the same. So we get the -4, and then the z to the 5th. And just as a reminder, that negative is going to cancel out because of the squared. And then we multiply that by the uncertainty in z squared. Okay, this last one, the sign, is a little bit different. Okay, everything else stays the same. So we got the x, y to the 1/3, and z to the 4th. Now, what's the derivative of sine? Well, it's just simply the cosine. Great. So we put sine and we put the cosine in there, and quantity squared sigma theta squared. All right, this is where it's going to get a little bit tricky because there's a lot of terms up here. Okay, we went through each one of these things, and this is the first one. And this is the second one, and this is the third one, and this is the fourth one. And if you notice right here, what we did is we also carried the squared to each term. So for example, let's look at the first one. So we have, instead of y to the 1/3, we square it, so we have y to the 2/3. Instead of just sine of theta, we square it, so we have sine squared of theta. Instead of z to the 4th, we square that, and remember, when you square when we square exponentials, you multiply them, and so there we go. Z to the 8th, and times sigma squared, sigma x squared. Okay, and we do the same thing with the rest of these, and so that's where we have the 1/3 becomes 1/9, and the -4 becomes 16, and all the way through. Okay, now q squared, let's look at our q again from the top. So q squared on the bottom, we have an x to the first, so that's where we get x squared. We get a y to the 1/3, and that's where we get y to the 2/3. We get a sine of theta, and that's where we get sine squared of theta. And then finally z to the 4th, we have to multiply when we square exponents, raise an exponent to another power, and so we z to the 8th. Okay, now let's look at each one of these terms. Okay, so let's look at this denominator to this first term over here. In fact, no, let's have everybody write this down on your paper, okay? And then let's separate this out and write down this term for each one of these pieces. And let's separate it here, separate it here, separate it here, and let's do one piece at a time, okay? Okay, so the first thing is, let's look at this with this first term. Okay, we got a y to the 2/3 on the top and a y to the 2/3 on the bottom, so those two cancel. We got a sine squared and sine squared, those two cancel. And we got a z to the 8th and a z to the 8th, those two cancel. So what are we left with? We are left with a sigma x squared on the top and an x squared on the bottom. So boom, there's our first term. Let's look at our next term, okay? This whole thing over this whole thing. Okay, so first off, we have a 1/9, and there's no 1/9 down there, so that drops down, boom. There's a sigma y squared, and there's no sigma y squared over here, so that drops down, boom. And now let's look at everything else. There's a z to the 8th and a z to the 8th, those cancel. There's a sine squared and sine squared, that cancels. X squared and x squared, that cancels. But this is the tricky part, okay? We got a 1 over y to the 4/3, and then we got a y to the 2/3 over 1. So remember when we got it on the bottom, and here we got it on the top, to multiply them, we got to take the bottom, or sorry, to change it from division to multiplication, we got to take the bottom and we got to flip it. And so now we're left with 1 over y to the 4/3 and 1 over y to the 2/3. Let's write that down on our paper. Okay, because now we're going to multiply 1 over y to the 4/3 multiplied by 1 over y to the 2/3. And when you multiply two of the same variable with different exponents, you add the exponents together. So what's 4/3 plus 2/3? That's 6/3. That becomes y squared. And that's 1 over y squared. And so that was kind of complicated, but there we go. We're just left with y squared. 1 over 9, remember 1 over 9, the sigma y comes down there, and this y to the 4/3 and the y to the 2/3 becomes just simply y squared. Cool. All right, let's look at this next term. This next term right here. The 16, there's no 16 on the bottom, so that drops down. The x squared and the x squared, that cancels. The y to the 2/3, the y to the 3/3, that cancels. The sine of theta, sine squared of theta, sine squared of theta, that cancels. The sigma z squared, there's no z squared on the bottom, so that drops down. So we got a 16 of z squared dropping down. But now what do we do about the z to the 10th? Z to the 10th divided by z to the 8th. That's, remember, this is 1 over 1 over. And if we want to flip them, we can. And so that becomes z to the 8th over z to the 10th, and we're just left with z to the z squared on the bottom. Z squared on the bottom. So cool. Oh no, wait a second, tangent? Let's do this, okay? We know the x squared and the x squared cancels, y to the 2/3, y to the 2/3, that's cancels, z to the 8th, z to the 8th, that cancels, sigma theta, that drops down. Okay, now we're left with cosine squared over 1 and a sine squared over 1, okay? Cosine over sine. Let's write this one down on our paper too. Let's write this one down. Okay, so let's not worry about the cosine squared at the moment, okay? Let's just think about cosine over sine. Okay, what is cosine? Cosine is adjacent over hypotenuse, and what is sine? Sine, write it down, is opposite over hypotenuse. So the two hypotenuses cancel, and now we have adjacent over opposite. What is that? That's a cotangent. But we're a little less familiar with cotangent, so let's just write it, let's flip it, and just do 1 over tangent. So it's 1 over tangent squared, because remember, it's not just cosine over sine, it's cosine squared over sine squared of theta. So that's tangent squared. Great. Okay, so let's look at that expression again on this next page. And we're just writing it down again. And we can take the square root of both sides and move the q over. And just as a note, look at this right here, this 1/9. Putting it inside the parentheses is back to 1/3, and putting this 16 back to there is 4. But wait a second. I just want to point out something really quick. What did we start out with? Let's look back at think about this 1/3 and this 4. What did we start out with? We had a y to the 1/3 and a z to the -4. Aha, think about that. Okay, there's our expression. Now I want to take one more quick note, thinking back to our original problem, our contrived problem, just so that we can do some error propagation. Think about error propagation is what about pi? What about irrational numbers? Well, you have, to really write down an irrational number without uncertainty, you would have to write down every digit, right? Well, you could do that, but that would be irrational. Sorry, bad joke. All right, so let's think about pi, okay? So the area of a circle, we're finding the area before we multiply it by the length. And so a student typically writes down the number 3.14. What about the uncertainty? All right, well, we know the next two digits, and so the next two digits is 159, And we're just going to write it to 0016, okay? So what's the ratio of those two numbers? 0016 over 3.14 is 0.0005, which is 0.05%. And so that's small enough, we can once again ignore it. And so our uncertainty for this one, the squared, because the squared, the 2 drops down, and is just simply the area times 2 times sigma d over d. Okay, so with that, now it's your turn. Everybody write down this equation. Q is equal to axy squared over z. Axy squared over z. And let's take a couple minutes to solve this. Don't forget, let's write down this whole expression first for every variable, and then work out the first piece and put it in parentheses, work out the second piece and put it in parentheses, and then the third piece and put it in parentheses. And don't forget that a is a constant, so remember the derivative of a constant is 0. All right, and once again, the solution will be in the comments. Okay, so let's move on. Okay, I wanted to share a final example with you with the Pythagorean Theorem. It's a little bit different because we got to think about some chain rules now, okay? Chain rules. But don't worry, we can do this. The chain rule is simply when you take the derivative of something, you have to first take the derivative of the outside, and then you got to take the derivative of the inside. Okay, so the Pythagorean Theorem. A squared is equal to b squared plus c squared, okay, or a is equal to the square root of b squared plus c squared. Okay, so sigma a squared is equal to partial with respect to b squared times sigma b squared plus the partial with respect to c squared sigma times sigma c squared. Okay, so let's look at the first partial, okay? So square root, that's the same thing as parentheses to the power of 1/2. Okay, so how do we take the derivative of that? Well, the first thing we do is we drop down the exponent. So we put a 1/2 out in front. Okay, now we have to subtract 1/2, or we have to subtract 1 from that exponent of 1/2, and so we get negative 1/2. Okay, negative 1/2. And so we're left with a 1 over the square root of b squared plus c squared. And now we got to look at the inside, the b squared plus c squared, and we take the derivative with respect to b. That second term is 0 because it doesn't have a b in it. The first term, well, what's the derivative of x squared? Well, the derivative of x squared is just simply 2x. So the derivative of b squared with respect to b is simply 2b, or not to be. Sorry. There's 2b right there. And now notice the 2's cancel out. And so when we square this and when we square the bottom, we're left with a b squared at the top, and we're left with just simply b squared plus c squared on the bottom, multiplied by sigma b squared. Okay. Now let's do the same thing, repeat the process with c. Okay, we'll take the partial derivative of this with respect to c. The first thing is, because it's raised to the power of 1/2, we have to first drop down that 1/2. Okay, there we go, right there. Now we have to subtract 1 from that 1/2, and we get negative 1/2. And so that whole term, square root thing, goes to the bottom. There we go, 1 over b squared, square root of b squared plus c squared. And now we have to take the derivative of the inside. Well, that first bit, that b, doesn't have a c in it, so that goes to 0. And now the derivative of c squared with respect to c is just simply 2c. 2c. Now that 2 and that 2 cancel. We square it, and so we have a c squared on the top, and we got a b squared plus c squared on the bottom. Boom. And we have to multiply it by that c squared. Great. Now we could factor out that term right there. And if we remember what b squared plus c squared originally equaled, that's just simply a squared. A squared. And so if we took the derivative and if we took the square root of both sides, we'd be left with sigma a is equal to 1 over a times the square root of b squared sigma b squared plus c squared sigma c squared. But there's a little trick to remember this formula. Let's move the a back on the other side and not take the square root, okay? So the Pythagorean Theorem. A squared is equal to b squared plus c squared. What's the uncertainty? Well, that's a tricky one to do the derivative. So let's just remember, it's a squared sigma a squared is equal to b squared sigma b squared plus c squared sigma c squared. Great. And then you can rearrange it when you get all the numbers. Okay. So if you didn't recognize all the, if you haven't had partial, or if you haven't had multivariable calculus, and you didn't recognize the patterns that from those problems up above, here's a really handy table, okay? And how to use this table? Well, these first couple terms up top are those first couple addition and subtraction problems we did. And there's the answer. Sigma x squared is equal to, now on this table, instead of q, I'm using x, and instead of x, y, and z, I'm using u and v. No big deal. Oh, great. Okay. And a and b are still constants. And so there's the first couple with multiplication, or with addition. Now here's a couple where we're just adding, or sorry, we're just multiplying or dividing by a constant. And there's a simple little trick, like if you multiply u by a constant, something with uncertainty by a constant, look, you just multiply sigma u by a constant. Easy enough. Same thing here, but if you notice this middle column, they're all the same thing. If you took the partial derivative of this, they're all the same thing. All right, next is those multiplication and division rules that we've looked at. Now next is the power rule, and then we got a couple other down here at the bottom. Okay, so how to use this table? Well, let's take a look. Let's go back to our most complicated formula without the sign part, okay? So we get x, y to the 1/3, z to the 4th, which is the same thing as z to the negative 1/4, okay? Now, if we were to scroll back up to the table, we could see that it's these formulas right here in the middle, and so using the multiplication one, let's just take each of these variables and say, take each of these variables, and we see that relationship. And so we get sigma q over q squared is equal to sigma x over x plus sigma y over y and sigma z over z. Okay, so that's the first part, but we can't forget the second part, okay? Can't forget the second part. Now let's consider the powers. Scroll back up and we look up here. Oh, the powers, we just dropped the power down in front and it's just sigma u over u. Great. So there's that formula right there. We drop the power down, sigma u over u. So we take the first power, that's 1/3, and we just put it down, 1/3. Great. We see the z to the negative 4. We drop it down. Boom. And that negative cancels out, and so we could rearrange it, take the square root, put the q on the other side. Boom, we're done. Easy enough. All right, this is your final test, okay, everybody? Your final test is to use the table to find the uncertainty for this. Uh-oh. That's a y cubed in the side of square root. Oh no, we're going to have to be dealing with fractions. And the x is also raised to the 1/2. All right, no, you guys can do this, okay? And anyways, that's it for today. The solution to this last one is in the comments. Thanks for watching this short video on how to propagate errors. Have a good day.